Let's say you're trying to figure out which kind of medicine works best for a specific condition. Drug A, B, C, D, or some combination of two or more. But you're not conducting a study of your own. You're doing a meta-analysis of existing papers. This might sound straightforward, but it can actually get pretty complicated pretty fast. If you were just comparing A and B, you'd be able to pick a few papers that studied each in isolation and do a head-to-head comparison. But the question you're asking is actually far more complex, with many more combinations and possibilities. For example, if one paper tests a combination of a set of drugs and another paper tests a different single drug on its own, how can you draw meaningful conclusions from the comparison? Let's say that first combination set proves most effective. How will you know which components of that combination are doing the heavy lifting and which are not? Welcome to the messy world of component network meta-analysis. In traditional network analysis, that's NMA, you're comparing complete treatments against each other. But component network meta-analysis, that's CNMA, is different because you're figuring out individual contributions. And that is mathematically brutal. That's the problem the authors of today's paper set out to solve. They've developed what they call a leave one out algorithm that can quantify how much each piece of evidence contributes to your final component estimates. On today's episode of Journal Club, we're going to walk through how it works, how well it works, and what it means for meta-analyses and systematic reviews. If you're already subscribed to our email newsletter, then you'll be getting this full episode delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.